this is the final lesson of the unit exponential and log function. We will be looking at solving a problem involving future value and solving a problem involving the Richter scale. For both of these, we'll be using the concepts of exponents and logs. The first problem involving future value, we'll be using this specific formula, which is a future value is equal to your regular investment times 1 plus I refers to interest rate per compounded periods per year. N is your number of investments minus 1 divided by your interest rate divided by the compounded periods. Generally speaking, this formula applies to when a series of equal investments is made at equal time interval. Let's say you're making $100, your payment's $100, and you're making it $100 per month. You want to know how, and you want a certain amount of money, how many of those investments do you have to make to arrive at that future value? So for this here, we have FV refers to the future value, R refers to your regular investment, and then in other words, how much you're paying every time period. And I is your interest rate in decimal divided by the number of compounded periods per year. The next one has to do with the Richter scale, and this was developed by Charles Richter in 1935, and he defined the magnitude of an earthquake to be the log times the intensity of the vibration of an earthquake divided by the intensity of a standard earthquake. So relatively saying, what's a standard earthquake? This earthquake happens and we have an earthquake of 4. It means it's 4 times 10 to the power 4 times more, much greater. So we look at 2 of these questions. So let's look at the first question. And you'll need a calculator. It doesn't have to be any scientific calculator that has your log function on it. So here's our first question. Determine how many monthly investments of $100 would have to be made into a savings account that pays 6% annual interest rate, compounded monthly, for the future value to be $100,000. Now, just a reminder, when you say compounded monthly, it means that every month interest is calculated. So it's interest on interest. So this is compounded monthly, and the annual interest rate is 6%. So this is your R, how much money you're putting in each time. And you want the future value to be $100,000. So this will be your FV. So we can put here 100,000. That's your future value. Your regular payment would be, how much is $100? So this is your regular payment, which is $100. Now the question is asking you to find N. How many monthly investment, how many payments do you have to make with this interest rate compounded monthly for you to arrive at $100,000 when you're investing $100 each time? So the I refers to your, so let's put it here, I refers to your interest rate. And this has to be in decimals. Divided by the compounded period. Now, we have an interest rate of 6%. Change that to decimals, so 6% is equal to 6 divided by 100, 0.06. So this is your interest rate in decimal. So we can put that there. Now, it's compounded monthly. So there are 12 months in a year. So therefore, the number of compounded periods in a year, should be per year, is 12. So I now is 0.06 divided by 12. Now we get our calculator out, and that was 0.06 divided by 12, 0.005. So now I is 0.005. Now n, we don't know, so we'll leave it as n. So we need to find that. Now we will substitute all of these values into here. So substitute these values into our formula. So f of v is 100,000. So we'll pour that out. R is 100. Put a square bracket. You have 1 plus your I is 0.005. Your n, we don't know. Minus 1 divided by your I, which is 0.0005. Next, we will solve this part divided 100. 100 divided by 0.005. So that will leave us with, so 100 divided by, so we want to simplify this further. So we divided by, give me 20,000. So this, so 20,000. Maybe 1 plus okay. So here we're simplifying. To give us this part here. Next, divide each side. So we divide each side by 20,000. So over here. So divide both sides by 20,000. This is 1. And this will leave us with 100,000 divided by 25. So we have 5 is equal to 1 plus 0.005 minus 1. So simplifying this operation, we'll end up at 5. Take this over here. So 5 plus 1 is equal to 1. Now 1 plus 0.005 is 1.005 to the power n. So 6 is equal to 1.005. Here we have an exponential function. What we do next is to take the common log of both of these because we want to find n. So take the common log of both sides. So we'll have here log, so it's become log 6. Now we're using base 10, right? So this becomes log 1.005 n. We use apply the power rule here. Or power law, I should say. So this becomes log 6 equals n log 1.005. Now we will solve for n. Next, solve for n. So n is equal to log 6 over log 1.005. And this is what we will need our calculator in this case here. So use calculator. So now we have log 6 divided by log 1.005. 359, so n is 359.25. So we'll round up. So round up. So we'll need 360 in investments. So in conclusion, you'll have to invest for 360 months because each month you're investing $100. So if you were to invest $360 for $100 360 times each month, you will arrive at a future value of 100,000. So you'll need 360 investments. Which roughly equal to about 30 years. So approximately just 30 years. So you will have to invest that money every month. You put into your account $100 for 30 years, doing it each month, for you to arrive at $100,000. Okay. The next one, we'll be looking at the Richter scale. And here we'll be comparing different earthquakes. Because the Richter scale basically is a comparison of the vibration of the Earth between an earthquake and a standard earthquake. So if you go back to Richter's formula, M is the magnitude of the earthquake, the log, the intensity of the vibration of the earthquake, and you're measured using a seismograph. So a seismograph is generally an instrument used for measuring earthquake, and it's normally that is 100 kilometers away from the epicenter of the earthquake. And generally you need three measuring instruments to do triangulation to arrive at the epicenter. So the intensity is compared to the intensity of a standard earthquake. So this will be the earthquake you're measuring, and this will be comparing it to the standard earthquake. So let's say standard earthquake is 1. So what is the magnitude of a specific earthquake relative to the standard earthquake? And generally it's measured in microns. Okay. So for each increase of 1 unit on the log scale represents a 10-fold increase in intensity. Because we're using it as a base 10 log, so that's why there's no subscript. It's base 10 log. For example, if an earthquake magnitude of 9 and another earthquake magnitude of 7, the earthquake that's magnitude of 9 is 100 times as intense as an earthquake that magnitude of 7. Because it's 10 to the power how many times more? So 10 to the power 2 is 100. So let's look at this question now. Here in June 2010, Ontario and Quebec experienced an earthquake with a magnitude of 5. In January the same year, Haiti experienced an earthquake with a magnitude of 7. An earthquake are a natural disaster. The last one in Haiti, the country still haven't recovered yet from it. So they are concerned for all of us. The question is calculate the intensity of the Haiti earthquake in terms of a standard earthquake. So here we go. This is the magnitude of the earthquake relative to a standard earthquake. So we'll use, so let's go to the first party, A. We need to get our data. Okay, so we need 5. So the first one, we want to find the intensity of the Haiti earthquake. So we need to find the intensity, which is the M, the magnitude. Right? So we know the magnitude of that earthquake is 7. So this is M. And what you need to find is I. So we have M is equal to 7. So we'll substitute the value for M into our formula for the magnitude of an earthquake. So substitute 7 for M in the formula. So here we have 7 is equal to log, now this is base 10, I over S. Now, S refers to the standard. Now notice we can write this, now the next step we're thinking about, write as an exponent now. And this is our knowledge of exponents come in handy. So we become 10 to the power 7 is equal to I over S. So this is base 10, so 10 power 7 is equal to I over S. So now for I, So we can change over here so we can look at the power 7. So I is equal to 10 to the power of 7 times S. So the Haiti's earthquake is 10 to the power of 7 times greater than a standard earthquake, whatever that standard earthquake is. Okay. So this would be for Haiti. Now, it's a calculating intensity of the Ontario, Quebec earthquake in terms of a standard earthquake. Now, the Ontario, Quebec earthquake is 5. I guess you could predict that. So B, so M is equal to log I over S. We have M is equal to 5. So 5 is equal to log. Next, we write as an exponent. So remember, this was 10, so it'd be 10 to the power 5 is equal to I over S. So I is equal to 10 to the power of 5S. So this earthquake now, here, so this earthquake was 10 to the power 5 times as intense as a standard earthquake. Now the next part, C, how many times as intense as the Ontario, Quebec earthquake was to the Haiti earthquake. So we're comparing the two. So essentially what we're looking at there is the intensity of the Ontario Quebec earthquake divided by the intensity of Haiti earthquake. So we know the intensity of, for the first base here was a Haiti, and we know the intensity for Ontario, Quebec earthquake. So basically we're going to divide the two intensities. So let's do that part here. So C, so the intensity of square, how many times? Okay, so we have the Haiti's earthquake divided by the intensity of the, oops, of the Ontario, Quebec earthquake, which is equal to, so we have Haiti is 10 to the power 7, and Ontario, Quebec earthquake was 10 to the power 5. So this gives us the result of 10 to the power 2, or 100 times. So the earthquake in Haiti in Haiti was 100 times more intense as the Quebec Ontario earthquake. So as the Ontario, Quebec earthquake. So whenever we're measuring the magnitude of an earthquake, we need to use the formula, or the Richter scale formula, to find the magnitude of an earthquake. And it's, by the way, the Richter scale is comparing it to a standard earthquake. So it's a comparative scale. Just give you intensity because it's just a large number. That's why we use log. So for practice question, you should check your understanding questions on, there are 2 questions I would like you to look at, questions 1 and 2 on page 431 and 433. So let's recap. Our goal today was to solve a problem using either exponent or logarithm involving future value. Oops. So first, we're solving a problem involving future value, and secondly, solving a problem involving the Richter scale. So you're given the formula for future value, and a situation created, and you need to find how many investments. And the second one is the Richter scale, the magnitude of an earthquake. The first question, we looked at finding how many investments you have to make so that you can have a future value of $100,000. We discovered it will take you 30 years or 360 investments. How about $100 each month? The next question, we looked at the Richter scale and how to use the formula to find the magnitude of an earthquake. And your task, one of your tasks, is to complete, well, check your understanding question on page, this would be on page 431. And question 3, 433.